Okay, just for starters, here's a system. That form we're using, really good looking for. Still ain't know how good looking, you can tell what it is. Oh, here's a system, solve it. Okay, and I'm gonna add a little to that. Solve graphically. It is by graphing the two equations and seeing where the lines intersect. And then solve by elimination. Okay, now the assignment on this stuff isn't actually due until a week from today. So if you haven't started it and don't remember what we did last time, don't feel too bad. But hopefully you go over your notes and stuff and what you did in class and try to reinforce it, because the longer you wait until after class, the more you lose and the less you're going to have when you need it. Still, open math is going to give you what you need. But let me just give you a hint here, okay? Solve graphically. The x-intercept occurs when y equals 0. The y-intercept occurs when x equals 0. So if you're solving graphically, if you let y equal 0, for example, in the first equation, you're going to get 0 here, and you're just going to have 7x equals 18. And the solution to that equation is going to give you your x-intercept, right? Because y equals 0, you're going to have a point 0, whatever. So you're going to get a point that probably won't be there, but just schematically, you're going to get a point in the x-axis, right? And then if you let x equal 0 and solve for y, you're going to get a point on the y-axis, right? Now, it's definitely not going to be here, because pretty clearly, if you let x equal 0, you're going to get a negative for y, right? It's not going to be up here. But I'm just doing this schematically. You get the x-intercept. And you get the y-intercept. And you have a line. Okay? So make sure that we're doing this. Okay? Very important to have a graphical connection. Now, some people have a complete solution right now. Some people are still pretty much just getting started. Okay? And maybe with a little error in finding x and y intercept. You do that for each equation, find out where they cross, right? Now, if you completed the problem, and what you're sitting around with nothing to do, a little more practice on a harder problem. Let's say you got the equation that I'm going to write down here. Okay, well, I'm just going to write down an equation, then I'll continue recording and say a little bit about it. So don't even bother with this if you're still working on the first problem, okay? Okay, here's a system of 3 equations and 3 unknowns. I'll say this again, but if you finish the first equation, I'll observe that if you multiply just one of the first 2 equations by a number, you'll be able to eliminate z, or multiply by another number, you would be able to eliminate y. I'd recommend going ahead and eliminating z. And then if you multiply either of the other pairs, here's a pair of equations. You got another pair, first and third equation, or the second and third equation. If you can also eliminate z between those two equations, well, when you eliminate z, you end up with an equation in x and y. Okay, so if you eliminate z between the first and second equation, say, and then between the second and third equation, you'll get two equations, both with just x and y. You won't have z left. And then once you have just x and y, it's just like one of these, okay? So you reduce the equation to a system of two equations by eliminating one of your variables. You could also eliminate y rather easily. And x would be a little, the numbers would be a little less convenient, but it would be difficult. So you can pretty much pick your variable, but I'd recommend starting with z. Again, worry about this only if you've got the first equation solved, or the first problem solved. And of course, I understand that if you've done the assignment for next Tuesday already, you'd be moving along much better on this. So when you do that assignment, I think you're going to be good. There's no reason you should feel any pressure to do it for the day. Still, we want to move on because this sort of thing tends to give people trouble. And these are the two things we want to be able to do by the end of next week. And we only have one more thing to do in the whole course, okay? Which is why I handed out these. And let me also comment that these sheets that I handed out, this is a beta version. I'm not guaranteeing that there aren't some bonehead errors on this, but I've checked it over a couple of times. I've got to go into my code and do corrections whenever they occur. I'd be very surprised if there weren't a couple of errors there. So if you find a problem that doesn't seem to make any sense at all, it might not be you. Okay. It might just be the problem doesn't make any sense because there's something I missed in the debugging. Okay. Okay. Well, let's see what this really looks like. So I'm going to go ahead and obliterate this graph because this real graph doesn't look like that. Neither equation has a graph that looks much like what I just drew. Remember, I was just showing you how it's done if you have the x and y intercepts. Okay, so let's see. Okay. Now, if 7x equals 18x is 18 sevenths, which you could write as 2 and 4 sevenths. It's always good to write out the fraction instead of immediately converting to the decimal, because you can locate that fraction pretty accurately without needing to do decimals. Okay. And if x equals 0, then we have negative 4y equals 18. So, and this is x equals 27. So y equals negative 18 over 4, which is what? Negative 4 and a half. And if you don't know how to convert these fractions to mixed numbers, review fractions. This is something you have to be able to do. We don't do a lot of it in this course, but when we do it, we need to be able to, because this is something that you learn to do in like 5th grade. Okay. You've had a lot of time to forget it because you probably haven't used it much since then. But it's easy enough that a 5th grader can do it, so make sure you know how to do it, right? Review if necessary. Okay, well, so the intercepts are 2 4/7, 0, and 0, -4.5. Now, the mixed numbers are going to be easier to locate on a graph. Some people have trouble locating these things, okay? Convert them to decimal, it's a little easier to locate them, but let me illustrate something a little more. Okay, so I'm not going to go through the details here, just mainly because I'm out of room. But if y equals 0, x is 18/3, right? That's not 18, it's -8. I knew we didn't have an intercept at -6. Okay, so x is -8/3, which is -2 2/3. Okay. And so y is 0. If x is 0, you get y equals -8/14. Which reduces conveniently down to -4/7. Now our graph. We need numbers on the y-axis as big as like -4.5, right? So we better line off the negative y-axis. We've got at least 5 units. Here's -5. The x-axis, we only need numbers as big as 3. Okay. So we really don't need any more. It wouldn't hurt to line off 5 of them, but I'm just going to do 3 of them. And I'm not really worried about whether my scales are equal. My units on the x-axis are bigger than my units on the y-axis, but all my units on the y-axis are the same, and all my units on the x-axis are the same. Okay, now it becomes easy to plot the intercepts. Okay, for the first equation, we get these intercepts, 2 4/7, 0. Well, here's 2. I can divide this up in this interval between 2 and 3 up into 7 pieces. I do 2, 3, 4, 5, 6, 7. And then I count over 4 of them, and I get something about here. You do it in decimals. Okay. 4/7 is that's 0.57 approximately, around 0.6. Actually, it's a little further over than what I would have done there, but I wasn't real careful. Okay, so you're going to have 2 4/7, 0, and 0, -4.5. Well, -4.5 is easy. You just divide the interval between -4 and -5 in half, and you got our 0, -4.5. So now we can draw a straight line, and there's our graph of the first equation. 7x minus 4y equals 18. The second equation, where in the world is it? Here it is. And the second equation, here are the intercepts. I'll use this and this. Okay, so we have Negative 2 2/3, 0. Well, here's negative 2, here's negative 3, and I divide this into 3 equal parts, and negative 2 2/3 would be here. And then we have 0, negative 4/7. Well, once more, I've got to divide an interval into 7 pieces. Let me do that a little more carefully. Okay, negative 4/7 is about here. And now I sketch a straight line through these points. Okay. Now I estimate my solution point is right here. Now, if I estimate that honestly, according to my graph, I get about 1.8 and negative 1.2. Okay. Now I contrive this to where you actually have a whole number solution. And if it's going to be whole numbers, well, what whole number is this close to 2, right? X equals 2 and y equals negative 1. Okay. Now there's no reason in the real world to expect that you're going to get an equation that gives you nice integer solutions. Okay. In a contrived problem like this, I think I even said earlier that the solution is a pair of integers. So you would expect that if I'm right about that, and you know, I did the mental arithmetic, it was all based on mental arithmetic. I checked it pretty carefully. It was all mental. Okay. And some days I'm kind of mental, but anyhow, we expect x equals 2, y equals negative 1 if it's integer solutions. Okay. You don't have to necessarily think about that, but it can be helpful. Now we do elimination. I'm going to leave this problem for another board. There you go. It's 18. Add 3x 14y equals negative 8. Yeah. Okay. Call this equation 1. Call this equation 2. If I do 14 times equation 1 and 4 times equation 2, I'll eliminate y. I'll look at my y variables. If I multiply this one by 14, I'm going to get, and multiply this one by 4, I'm going to get the same number, but this is going to be negative. Okay? So I do that, I get 98x minus 56y equals, now I've got to multiply 14 by 18. Why in the world did I do this? Well, okay, 10 times 18 is 180. 4 times 18 is 72. 180 and 72 is 252. Then I multiply this equation by 4, which is a whole lot easier. I get 12x plus 56y equals negative 32. And that's going to work out very nicely. Okay. Now we see that if I add these, the y's go away. Now you might have chosen, which, and it would be wiser to do so. You might have said, well, I don't necessarily have to multiply by 14 and 4. I could, 2 goes into both of these. That's a hint. I could multiply it by half as much. I can multiply this by 7 and this by negative 7. 7 times this is negative 28. 7 times this is 28, right? Okay. So it's maybe more convenient certainly more convenient to multiply by 7 than it is to multiply by 14. Okay. So anyhow, I add, and I get 110x equals 220. So x equals 220 divided by 110, which is 2. So it does come out 2. Now our solution, we estimated 1.8. That's close enough for a hand-drawn graph that we're pretty sure that's right. Okay. Now we take x equals 2, plug it into either equation. Now I can draw an arrow out here easier than I can another one, and then this equation comes around down here and gives us 7 times 2 minus 4y equals 18. And now we just have one variable we can solve for y. So we get 14 minus 4y equals 18. Subtract 14 from both sides. Negative 4y equals 4. Y equals negative 1. Of course, I want you to fill in the steps here because still seeing too many fundamental algebra errors, okay? You skip steps here and get it wrong on the exam, it's going to cost you more than if you show me the steps. And especially if you say, doggone, I know that isn't right, but here are my steps. I'm not sure where I went wrong. I'll be much more generous with partial credit, okay? Because you're thinking along lines that you can build on in later courses. Okay. Now, it works out better, but the same. Doesn't cost you anything to do this, except the numbers are less convenient. So it's better because it's more convenient. Multiply 7 by the first equation, and two times the second equation, forgot where I was. Okay, as I said before, we get then 7 times this gives us 14x minus 8y, 28y. No, sorry, 7 times 7 is 49x minus 28y. And 7 times 18 is 126. 7 times 10 is 70. 8 times 7 is 56. 70, 56 is 126. So I think that's right. Always double check my arithmetic. I'm pretty good at it. But not good enough not to check myself. Okay. Then I multiply the second equation by 2. It almost looks like a negative 2, so let's make sure. Same right, okay. And we get 6x plus 28y equals negative 16. We add, and we get 55x equals 110. X equals 110 over 55, which is 2. Same as what we got here. Okay. Nothing wrong with this. This is a little more elegant. Numbers are easier to work with, but I'll take what I get. I recommend you try to do this, but and Open Math is going to coach you on that. Okay, then we plug this in to this equation. We get something. Well, we're going to get the same thing now because we're just going to plug 2, say, into the first equation, right? And we're still going to get, it's going to be identical to what we have here. So this then, this implies this. And again, that confirms, or that's confirmed by our graphical solution. These lines cross near to -1. Now we check by substituting 2 and -1 into the original equations. Even though this gives us good confirmation, we check. So we'll say the solution x equals 2, y equals -1. Check. Well, we have 7x minus 4y has to equal 18. And I'm going to say do the arithmetic, and that checks out. You got 14 plus 4, which is 18. And you can do that very easily. And then we check the second equation. The first equation gives us this second equation. 3 times 2 plus 14 times -1 equals -8. And that checks out. On to test or exam, I'd want to see all of this. Okay. Now, if you really can't handle the fractions, you can convert to decimals. I'll live with it. Okay. Kind of prefer to see the fractions. If you make a mistake in converting to your decimal and don't use the mixed numbers, you're going to be less charitable. So if you got even one intercept off because of that, you're going to lose some points because your solution is not going to match. But if you recognize that your solution doesn't match, but that this thing checks out, you say, well, I must have screwed this up. I'm not sure where. Say all that, you probably get 8 points out of 10. Okay. Don't say any of it. Probably get 5 points out of 10. Maybe 6. Okay, close to Christmas. So I'll probably be as generous as I can bring myself to be. And I want to be as generous as possible. Of course, I don't want to send you out into the cold, cruel world with any more faulty mathematics than absolutely necessary. Okay, so I want to see things done, and I want to see them communicated and written out somewhat coherently. Right? Again, 2 things. Okay, well, the rule in the testing center is you can't use your phone, you can't use your calculator, you got to use their calculator. Okay. So, I had one person who did that, but it didn't seem to make a lot of difference on the test, so I kind of overlooked it. But not going to overlook it on the final. If you're in there using a phone or a calculator that's not authorized, you're going to have to take the test again. Okay. A little bit of the fault there is mine because I usually make that very clear in the instructions for the test, and I overlooked that on this test. So it wasn't as clear as it should be. And the testing center wasn't as clear as they should be. Okay, so that's another reason I kind of overlooked it. Okay. Okay, well, let's move on. Let me grab the board to work on, because I probably ought to demonstrate this. Anybody get a picture of that? I had it all set up for you. I don't understand why you didn't get your cameras out in time. Oh, kind of hurt my big toe a little bit. You're still going. And also bumped my shin. I'm sorry to pull that a little bit. Boy, I'll tell you. All very minor. I'll leave it there for now. Probably trip over it now. I can't see the floor because of the stupid mask. We got to wear these stupid masks. For very good reason, we don't want health to be any worse than it is. It's pretty bad. People end up with brain fog. People end up with year-long symptoms, maybe lifetime-long symptoms. We don't want that. Okay, well, here's our system. And I'll work from this side to this side. Write it out again. And we're not going to try to graph this, okay? Because each of these is a graph of a plane in 3 dimensions. Maybe a plane like this and a plane like this that intersect along some line, and then a third plane that intersects that line somewhere in 3 dimensions. Okay, now I can do that. My multivariable calculus students can do that, but I certainly don't expect you all to be able to do that, okay? We still kind of want to have that geometric perspective. You've got 3 planes in space. In general, 3 planes, none of them parallel to each other, will always meet in one point. 2 planes will meet on a line. The third plane will then cut that line at a single point. Okay. So the planes are parallel. Well, that's, we're not getting into that yet. But we're setting the stage for being able to do that because it's very powerful. There's some very powerful mathematics around this. So in case you get to where you're using that mathematics and it does come up in data processing, this might come up with 100 million variables. Okay, instead of just 3, maybe 100 million variables. And you have to be able to understand how that works. Unlikely you'll need to do data analysis at that level. And if you do, it's probably going to be with a CAN program. So don't worry too much about it. Still, the picture is kind of important. Okay, well, enough of that. We want to eliminate variables. So we want to eliminate here's 1, here's 2, here's 3. I'm going to write them out again, just so we can look at them. I'm writing out 3 instead of 2. Right. Always let me do what I said I was going to do. Hope I do it right. Okay, well, notice if I multiply the first equation by 2, I'm going to get a 4z. And just add that to the second equation. Z is going to go away, right? Okay. I could as easily have done something similar here with the y. I could have eliminated y. Okay. But I'm going to choose to eliminate z. And it's kind of 6 half 1, 6 of one half dozen of the other. Whether you choose to eliminate y or z, it's going to be very similar either way. Okay. Eliminating z. So now this is 1 and this is 2. Okay. Call it 1 half and 2 halves and distinguish. That's it. That's equation 1 and equation 2. Okay. Multiply the first one by 2, I get 6x minus 8y plus 4z equals 2. 2 times 3 is 6, 2 times -4 is -8, 2 times 4, 2 times 2 is 4, 2 times 1 is 2. And then the second equation is just what it is. I don't need to multiply it by anything. Fair enough. Then you see now when we add these, we've eliminated Z. Now, we don't do any more with this until we get a second equation for X and Y. If we've got a second equation in X and Y, we can just do what we did originally. We have 2 equations and 2 unknowns. So now, we're going to eliminate Z from what 2 equations? Well, I would choose 1 and 3. Because I can do that if I multiply 1 by -5 and 2 by and 3 by 2, I get -10Z and 10Z, right? Okay. If I just look at these, I see what I need to multiply this by, what I need to multiply this by in order to eliminate Z. And then, of course, I multiply the entire equation by that. I could have chosen these 2 equations, or I would eliminate this or multiply this one by 5 and this one by 4. Then it would be multiplied by negatives, right? Okay. But the numbers would be a little bigger. So I'm going to choose equations 1 and 3. So here's 1 again. 3x minus 4y plus 2z equals 1. And 3, which is 5x plus 2y minus 4z equals -3. I just copied this thing down instead of this. This is going to be very helpful because this will be the same as this, right? So that wasn't a very smart thing to do. I'm just being careless. So let's go ahead and see if we can wipe this thing out as neatly as possible. And we've got now 6x minus 3y plus 5z equals 8. Okay, now to multiply the first equation by -5 and the second by 2. Now you'll get much better after you do the open math assignment on 2 equations and 2 unknowns at figuring out what variable to match up and how. But we want to see if we can do it this way. Okay, so 1 times -5 gives us -15x plus 20y minus 10z equals -5. Made myself put enough room, did I? Okay, again, 5 times 3 is 15, but you got to have a negative. 5 times -4 is -20, but the negative makes a plus. 5 times 2 is 10, but you get -10 because it's -5. 10 -5 times 1 is -5. Then 2 times the second equation gives us, well, 2 times 6 is 12. 2 times -3 is -6. 2 times 5 is 10. And we get 2 times 8 is 16. Now if we add these, z goes away again. And we end up with -3x plus 14y equals 11. So now we have excuse me, 2 equations in X and Y. And we can solve these two equations just as we would any other system of two equations. So we get I'm going to give myself enough. 11x minus 6y equals -1, and negative 3x plus 14y equals 11. So this is equation 1. This is equation 2. Not real convenient, but if we multiply this equation by 7 and this equation by -3, or by 3, okay. 7 times 6 is -42, 3 times 14 is 42. If we don't see that, we can always multiply this one by 14 and this one by 6, okay? Again, you're going to get better at that in the first of the assignments it's due next week. So by the time you get here, you'll be able to match these up pretty easily. So I'm just going to go do, just to keep the arithmetic a little easier, 7 times the first one, and 3 times the second one. So 7 times 11 gives us 77, 77x, minus 7 times 6 is 42y, equals 7 times -1 is -7. 3 times -3x is -9x. Plus 3 times 14 is 42y equals 33. So those numbers aren't terrible. We get 68x equals, but I'm not going to like that much. 26. Nope, I really don't like that. I don't believe it's going to come out right. Anybody say anything totally ignorant that I did? Very likely there's something. One back.
Negative. It's supposed to be this big.
Hang on. Let me put this on pause. Come up to the board and point out my error. Oh, this has gone so well, but you know what I did? This equal sign is not written very well, and I saw a -3 here, and that's what I wrote down. Okay, if I'd written my equal sign a little more neatly, I probably wouldn't have done that. That's going to be 3. And then I'm going to get 3 here. Then I'm going to get 5 here, right? Okay. So I should have in this equation, instead of -1, this should have been 5. Let's see how this works out. Then when I multiply by 7, I would get 35, and that is going to work because 35 and 33 is 68. Okay. So putting the correct equation together with this one, I get what I expect to get, which is x equals 1. Okay. So I get x 68 over 68, which is 1. Well, I take that solution for x, and I put it in here, and it gives me 11 times 1 minus 6y equals 5. So 11 minus 6y equals 5. Negative 6y equals 5 minus 11. Negative 6y equals -6, so that y equals 1. And that's what I intended. Okay. Now we plug that into equation 1. Both the x and the y go into equation 1. So here's equation 1. That could be equation 1, equation 2, or equation 3. But in equation 1, we get 3x minus 4y plus 2z equals 1. The first equation is this. And then if we plug the value of y in for y, plug this value of x in for x, and we get 3 times 1 minus 4 times 1 plus 2z equals 1. That gives us 12 minus 4 plus 2z equals 1. Well, that's messed up because I thought z was going to equal 1. No, it gives us 8 plus 2z equals 1. So 2z equals negative 7, and z equals negative 7 halves, which is negative 3.5. Now that should check if we plug those numbers in here. If x and y are both 1, this gives us 7. Subtract 7 from both sides, we end up with negative 4. Doggone it, z should equal 1. And we get negative 7 halves. I'm copying these down correctly. I am 3 minus 4. What's 3 times 1?
3.
Huh? It's 3, right? 3 times 1 equal to 12. So what did you let me do that for? When do you do that? Or did I do that? I did that. Okay. That should be 3 minus 4 equals 1, which is negative 1 plus 2z equals 1. So the 2z equals 2 and z equals 4. Okay. Okay, so be careful like I'm not. All right. And then we check. Equation 1. I'm going to manufacture that chart. I don't want to buy from them yet. Okay. 3 times 1 minus 4 times 1 plus 2 times 1 equals 1. And that's going to check out. 3 minus 4 plus 2 is 1. This is equation 1. Equation 2 would give us 5 times 1 plus 2 times 1 minus 4 times 1 equals 3. Well, 5 and 2 is 7, minus 4 gives us 3, right? So that checks. Ordinarily, you got to do a little more arithmetic because ordinarily you get fractions and all kinds of nasty things. So I'm just illustrating the process. It's usually a little uglier than this. Okay, plugging 1, 1, and 1 into the third equation. 6 minus 3 is 3. Add the 5, you get 8, and that checks. And we don't have a graphical solution. So I'm not even going to talk about where the planes intersect, although it'll be the point 1, 3, 8 in three-dimensional space. Okay? Three-dimensional Cartesian coordinates. All right. Well, hopefully that gives you just about everything you need to do, need to be able to do to get all the homework for next week. Finals coming up. If you happen to get a chance to do it all, that's fine. If you have problems, we're going to spend all week on it. I do strongly encourage that you pay a lot of attention to what I just handed out. That's going to be probably at least 80% of your final exam off of that sheet. Not the exact numbers, but those types of problems, okay? You don't know which ones you're going to get, be sure you can do them all.